Determinants and their applications. What is a determinant? A determinant is a value that can be calculated from the elements of a square matrix through various methods depending on the matrix. For example, in a 2x2 matrix, we see that the matrix A has values A, B, C, and D. By multiplying the values of A and D and multiplying the values of B and C, we subtract AD minus BC to obtain the determinant for matrix A. To find the determinant of a matrix of order greater than 2, we must find the minors and cofactors, which can be done through a method called cofactor expansion. Applications of determinants. Determinants can be used for things such as topography and economics. Topography by finding relative extrema within a given region, and economics by finding equilibrium prices between two products. Today we're going to be talking about topography and its relation to determinants. Let's say that a topographer wants to find relative extrema of a region of a mountain best modeled by the function negative x cubed plus 4xy minus 2y squared plus 1. For a topographer to find relative extrema based on a region, a topographer must apply the second partials test. What is needed? Critical points, second partial derivatives, and the determinant. With the given function, we find the first two partial derivatives, we equal those to 0 and find the values of x and y. For the critical points, give us the values 0, 0, and 4/3, 4/3. We must then find the second partial derivatives, which can be done by deriving the first two first partial derivatives, both with respect to x and y. We see that they give us fxx is equal to negative 6x, fyy is equal to negative 4, and fxy and fyx is equal to 4. We must then find the determinant by plugging in the second partial derivatives with critical points. Up top, we see that the general matrix for the second partial derivatives gives us negative 6x, 4, 4, and negative 4. And finding the determinant of that matrix gives us 24x minus 16. Plugging in the critical point 0, 0, we see that it gives us the values 0 minus 16, which is equal to negative 16. Plugging in the critical point for 4/3, 4/3, we get the value 24 multiplied by 4/3 minus 16, which is equal to 16. Finally, we then compare both determinants from the critical points. If the determinant is greater than 0, then there is extrema. It is a minimum if f of xx is greater than 0, and the maximum if fxx is less than 0. If the determinant is less than 0, then the critical point is a saddle point. It is nor a min or a max. If the determinant is equal to 0, then the test fails. The critical point 0, 0 is a saddle point because the determinant of 0, 0 is equal to negative 16, which is less than 0. The critical point for 4/3, 4/3 is a relative maximum. This is because the determinant of 4/3, 4/3 is equal to 16, which is greater than 0. Now plugging in 4/3, 4/3 into the second partial derivative, both with respect to x, we see that it's equal to negative 6 multiplied by 4/3, which is equal to negative 8, meaning that it's less than 0, resulting in a relative maximum.